Container storage interface is a vendor user interface to bridge container orchestrator and the storage providers. It was published about 1 year ago. Until now, lots of storage systems already claim to support this protocol. The adoption of CSI in Yarn enables us to support various of storage systems as long as they are compatible with CSI. The way CSI works, it defines three gRPC services, including identity, controller, and node. Each storage system needs to provide a CSI driver which implements all the necessary services and the APIs defined in CSI. And then the container orchestrator such as Yarn only need to talk to the CSI driver through the common and standard container storage interface instead of talking directly to each storage system. This actually helps a lot to avoid to maintain lots of customized code for each storage system. To let it work in Yarn, we start to support specify volume as a resource. Here's a very simple example how a volume resource looks like. It's associated with the value and the unit, and this actually defines the capacity of the volume. And in the attributes field, we are able to specify multiple volume attributes as long as can be recognized by the CSI driver. Some important ones are the volume, such as the volume ID. This is required if we are using the pre-provisioned volume. This is the identity of the volume Yarn will be depending on. And the driver name. The driver name is the CSI driver's name. It also should be the name returned by the get plugin info API call. And this is the how Yarn to know which driver to talk with for the particular volume resource. And the volume amount is actually the parse where Yarn will mount the volume onto the container. So this is also the parse for the application running in the Docker container to access the volume data from. And the access mode defines how the volume can be accessed. There are a lot of more attributes can be specified, and for the more information can be referred from the CSI specification. This chart introduces how the deployment looks like when Yarn works with a storage system through CSI. On the master node, along with the resource manager, we have a volume manager. This is a new module which is responsible to manage all the volumes known to Yarn. And on each node manager, we have a CSI driver adapter deployed, and also we have a CSI driver deployed. The CSI driver is the third party process which should be provided by each storage system, and it ships three services. And one controller service must be existing one instance on the cluster, and the node plugin must exist on each of the node. This is the deployment requirement. It's also defined in the CSI specification. And the CSI driver adapter is the Yarn module, which is responsible to delegate the call from Yarn side to the CSI side. So this is actually how we isolate the Yarn side messages from the CSI side messages. And both resource manager and node manager will talk to this module, and then it will process the call to the driver. And when the containers are launched on the node manager will do the volume amount on the local file system, and the local file system will be pointed to the container through the mount point. This is using the Docker bind mount. And then we're going to give a short demo about how to attach Ozone volume to Yarn containers. This is you will see how simple it is to using volume resource in Yarn. The workflow looks like first user need to write the service specification and submit the job through Yarn native service user interface. And of course, you will need to specify the volume resource in the specification. When resource manager finds there's a volume resource in the container resource request, and it will then go to the talk to the CSI driver, which of course through the adapter, and going to validate if the volume request can be satisfied. The CSI driver will go to the storage system to validate the request. And in our case, in this example, we're using the Ozone as the storage system. When the resource manager found the request can be satisfied, and it will go ahead to allocate the container for the AM, and the application master then will launch the container on the node manager. Before the container is launched, the node manager detects there's the volume resource inside, and it will talk to the CSI driver on the same node, which is particularly to the node plugin, to do the node publish, those kind of operations. And then the node publish will help to mount the volume to the local file system, and then the node manager starts the container and do a bind mount from the local file system to the container's mount point, and then it will help to expose the volume to the container through that mount point. Then when the application starts to run, we open the application's UI. We can see that the UI is loading the application is loading the data from MNT data sample.db. This is actually the mount point we gave in the resource specification, where the data is from the volume. Then we're going to see the real demo. So this is the cluster, and let's take a look about the service specification first. Okay. In the service spec, we're going to specify how many containers we're going to run, and we need to specify the Docker image we're going to use. Now, this is a simple Docker image to run a PHP web application, and it loads the data from a SQLite database file. And then pay attention to this part. This is the resource definition, and in the additional field, we are adding the volume resource here. So it gave us the value, the unit, and the attributes, including the volume ID. And the volume ID is specified as the CSI-volume-01, which is the volume I created before using before this example. Actually, from the Ozone UI, we can see this is the volume. This is the volume, and this is the data. There are 3 files, so I put in the volume, but this is the data the application we're going to load. And this is the mount point. We can also take a look how the application looks like. This is the PHP code, which is very simple. It actually loaded a database file from MNT data sample.db, and remember, this is the mount point giving the resource specification, and this is supposed the volume will be mounted to, and it loads the data from this database file and display the records in this table. Then let's go to launch the job. We'll use the REST API to launch the service job, and it will need a few seconds to run. Let's just wait for ensure the application is running. Okay, started. And then we can access the UI. This is the UI of the Docker container. You can see the UI is loaded, and this file is from this is a database records from this database file, and we can actually go inside of the container. Okay. And we know that we have mounted the volume under mnt data, so we're able to see all the files here. This is exactly the same files we put in the volume here. So using this example, it's actually using a very simple web application while loading its data from a database file which is stored in the external storage system. And also we can leverage this feature to build some more complex application to store the data store their state into the volume and persist the data into the volume. And when we do the recover or failover, recover, restart, we can still fetch the data from the volume without losing the state. So this is how you can see it is very simple to use the volume in Yarn and with the CSI and the volume resource. Thanks for watching.